You know the feeling. We've all been there, right? You're the only car on the road, sitting at a red light, staring at an empty intersection. It is one of the most universal frustrations of modern life. But what if the fix isn't about building more roads? What if it's about making our signals smarter? Today, we're going to dive into a showdown between our old, dumb traffic lights and the new AI contenders that are fighting to cure congestion once and for all. Okay, just take a look at this. This is what we're up against. It's this beautiful, complicated dance of steel and light. But for decades, the choreographer calling the shots has been nothing more than a simple, unthinking timer. And that is the heart of the problem we're going to unpack. Of course you have. We all have. And in that moment, it hits you. This light isn't thinking. It's not seeing you. It's just blindly following a schedule that was programmed maybe months or even years ago. And that little daily annoyance, when you multiply it by millions of us, adds up to a colossal problem. So how big are we talking? Well, get this. The Federal Highway Administration estimates that bad signal timing leads to over 295 million vehicle hours of delay. That's just in the US, every single year. It's an absolutely mind-boggling amount of wasted time, wasted fuel, and pure frustration. So the fundamental issue here is that the tech running our daily commute is basically stuck in the past. To really get why the new stuff is so revolutionary, we've got to first understand just how old the old stuff really is. You know, what's truly wild when you look at this timeline is how little the basic idea has changed. I mean, we went from gas lights run by a police officer in 1868 to computers in the 50s, but the core logic? For most traffic lights out there today, it's still just a simple, fixed schedule. It can't adapt to what's actually happening on the road in front of it.
All right, let's properly introduce the reigning, but let's be honest, aging champion. The system that's in charge of most of our intersections is simple, it's reliable, and oh boy, is it inefficient.
So the fancy technical name for this system is round-robin scheduling. But it's exactly as simple as it sounds. You know, lane 1 gets a green light for 30 seconds. Then lane 2 gets its 30 seconds. Then lane 3. It doesn't matter one bit if lane 1 has 100 cars backed up and lane 2 is completely empty. The schedule is the schedule, period. And this quote from the research just nails the problem. It says, the system is inefficient, especially in non-uniform traffic conditions. What does that mean? It means it works okay when traffic is perfectly balanced. But when does that ever happen in the real world? During rush hour or after a big event, traffic is never uniform. And that is exactly when the system totally breaks down. But now, new challengers are stepping into the ring. And these aren't just timers, these are learners. This is where AI, and specifically a really cool field called reinforcement learning, comes in to teach these old traffic lights some incredible new tricks. Now, it turns out there are a couple of ways to make a smart light. The simple adaptive way is a decent first step. It sees a long line of cars and goes, okay, I'll extend the green light a bit. But the advanced AI approach, that's a whole other level. It doesn't just react to what's happening now, it learns and predicts what will happen next. It's like the difference between a chess player who only thinks one move ahead versus a grandmaster who sees the whole board. So you might be wondering, how does an AI actually see the road? Well, it's not looking at a video feed like you and I would. Instead, the road is broken down into a grid of these little cells. And for each cell, the system just gets a simple binary input. Is there a car here or not? A 1 or a 0. This creates a digital snapshot, a language of numbers that the AI can instantly understand and act on. The best way to think about it is that the AI is playing a video game. Its actions are changing the lights. And its goal is to get the highest score possible. And what's the high score in this game? It's reducing how long we have to wait and making those lines of cars shorter. It's constantly trying out new strategies to find the perfect sequence of moves to win the game. So, we have the old guard versus the new contenders. How do we figure out who's actually better? Simple. We make them fight it out. Researchers built a traffic simulator, basically a digital arena, to unleash these different algorithms on a virtual intersection and see who would come out on top. And to make it a fair fight, they threw 3 different situations at them. The first was uniform traffic, kind of a lazy Sunday afternoon where cars are flowing evenly from all directions. This is where the old round-robin system should do okay. But then they threw in 2 imbalanced scenarios, which are much more like your classic morning commute, with 90% of the traffic piling up on one main road. This is the real test. And wow, the results speak for themselves. Just look at this.
On the left, with the old round-robin system, you see those queue lengths, the lines of cars, spike way up and just stay there. That's a long, frustrating wait. Now look at the right. That's the AI. It sees the heavy traffic coming, it adapts on the fly, and those lines of cars just melt away. The difference is incredible. And here it is, the final scorecard. This table shows what percentage of the time drivers were stuck in a really long line. With the standard round-robin system, a painful 80% of the time. The simple feedback model helps, dropping it to 48%. But look at the advanced AI models, Deep Q Network, or DQN, and Advantage Actor Critic, or A2C. They dropped that time all the way down to just 30%.
Let's just pause on that for a second because this is the whole story right here. In the kind of rush hour traffic that most of us deal with every day, these AI systems cut the amount of time we spend stuck in the worst traffic lines by more than half. That isn't a small tweak. That is a complete game changer.
Okay, so a computer simulation is one thing. That's fantastic. But the big question is always, does this work in the real world? And the most exciting part of this research is that the winning algorithm didn't just stay in the lab. It got put to the test on a simulation of a notoriously busy real-world intersection. And here it is. This is a digital twin of the J.P. Nagar-Saraki signal in Bengaluru, India. The researchers took their champion AI from the simulation, A to C, and dropped it into this real-world scenario to see if the amazing results would actually hold up under pressure.
And they absolutely did. It worked. On the real-world test, the longest line of cars you'd see with the old system was about 60 vehicles long. But with the A2C algorithm in charge, that peak queue length was slashed down to just 35 vehicles.
That's a reduction of nearly half in the longest, most frustrating lines of traffic. On a model of a real street with real traffic patterns, the AI proved it wasn't just a lab experiment. This is a real strategy that can dramatically cut congestion.
So, what's the next frontier? Well, the evolution doesn't just stop with a smarter traffic pole on the corner. The next great leap is something called Vehicle to Everything, or V2X. This is a future where our cars are constantly talking to each other, to the roads, to the network, a world where we might not even need physical traffic lights at all. And that really leads to the final, kind of mind-bending question. We've spent all this time trying to build a better, smarter traffic light. But what if the ultimate solution is to get rid of it completely? To make the signal virtual, beam directly to the cars and the drivers who need it? This is what that future could look like. A world where the signal isn't hanging on a street corner, but it's just a simple, clear instruction right on your dashboard. It's a system that could finally bring an end to the universal frustration of waiting for a light to change on a completely empty street.